6-1, day one, pre-lesson. So, brand new unit, brand new information, with a lot of talk of domain, range, asymptotes, and behavior all coming back. So be prepared. But let's get into the new stuff. So what the new stuff we're going to be working with a lot is based on this thing called exponential function. What is an exponential function? So you're going to be dealing with a whole bunch of exponential functions. Don't be afraid. So this is the generic form of all exponential functions. But this letter A and that letter B, they must be constants. They can't be variables. Now, I'm just giving you the groundwork for what an exponential function is. So let's take a look at these yeses. There's my A, there's my B. It's like, yep, they're constants. Constant just means a number. It can't be a letter. So there's my A, there's my B. That's good. Now there's a hidden little rule also. This little power will always be a variable. Could be T for time, X, just random X. So it's like, yep. All right, how about, why are these no's? Well, because my B is a variable. So that can't work. What's wrong with this one? Well, that pi up there is actually a number, 3.14. We need a variable up there in order for it to be considered an exponential function. Now, this is an equation, works just fine. This is an equation, works just fine. But the rules that we're going to explain would not apply to these, but they would apply to these. So with that being said, I don't think they're going to throw you zingers like this right away, if at all. We're going to stick with this. Now, there is a little sneaky one that I want to talk to you about, and it's like that. You're like, well, where's the A? Well, the A would be a 1, so it's 1 times 2 to the x. So A is 1, B is 2. A little sneaky one, okay? Now all of a sudden I'm changing gears and I'm introducing you to some rules of exponents. So look, it's an exponential function. We better have a really good grasp of our old Algebra 1 rules. I just know it's been a couple years. So here we go. 3 cubed is 27. 3 squared is 9. 3 to the first is 3. You already see a pattern? Divide by 3. Divide by 3. Let's keep going. So now look at it. 3 to the 0 power. I know a lot of you would say, well, that's probably 0. But look, the pattern doesn't say it's 0, because what's 3 divided by 3? 1. Do not forget this rule. Anything to the 0 power is 1. That's going to be very significant, because you can see we're going to have numbers possibly to the 0 power. You have to know what it is. Well, if we just keep on going, 1 divided by 3 would be 1 over 3, which look, see that negative exponent? Essentially what you do is you put 3 to the first downstairs. It just works. So on this one, that negative exponent just says take 3 squared and put it downstairs. So essentially that's what we're doing. So that's another representation of 1/9. Okay, let me clear the board here a second. So just a quick reminder, graphs or functions that you should be becoming very familiar with. Y equals x, that would just be a line. Y equals x squared, parabola. Absolute value function, remember it's a v. Square root function, kind of looks like that. Remember the domain, x can't be negative, you can't have the square of a negative. Cubic, you can have negatives, so if you just keep plugging numbers in, it actually looks like this. The cubic root, I should say, not cubic. Why am I showing you these? Well, number one, for review. But number two, remember what we're studying? We're studying exponential functions. So what that really is, it's something in addition to this that you need to just kind of know what it looks like. Now, I'm not just going to throw you to the wolves. We're going to build that concept a little bit. So give me a second. So whenever we introduce you to a new type of graph, it's always good to, just plug away, throw some numbers in there and plug them in and see what happens. Eventually, we want to get away from having to do this all the time. So there must be like a pattern, a certain look that these have. And I'm going to show you that they do. If we put a -2 in right here, we get 2 to the -2. Now remember my little rule? That negative exponent just means put 2 squared in the bottom. Well, that's 1/4, which is 0.25. Now what about if I had -1 in for x? That means put 2 to the first down the bottom, so I'd have 1/2 or 0.5. Now if I put a 0 in here, 2 to the 0 power is 1. If I put a 1 in, 2 to the first is 2. If I put a 2 in, 2 squared is 4. 2 cubed, see, 2 to the third power will be 8. Now let's go ahead and plot these. Now I'm going to start with this. Notice that's my y-intercept, 0, 1. It's a good place to start. And I'm going to branch away from there. So -1.5 would be right about there. -2.25 is like there. And we can kind of see, so it's going to, that's horrible right there. Sorry about that little wave. Then we're going to go to the right, 1, 2. And then 2, 4. And you can see that it's going to go like that. Now, you've seen your first graph of an exponential equation. So we're going to lock that in, like, oh, so this is kind of like a parent function? Yes. Let me show you one more thing. So I know you guys have been dealing with a lot of transformations, vertical shift, vertical compression, moves right, moves left, moves up, down, all that stuff. That's not really what I'm going after, but you might think it is, so hold your thoughts. So all I did was change the 2 to a 3, and let's see what happens to the graph. So I use a red marker, let's put the -2 in and see what happens. So it's 3 to the -2 power simply means put 3 squared in the bottom. So that's 1/9. I'm going to leave it as a fraction. If I put a -1 in there, so there's 3 to the -1. So that would be just 3 to the first in the bottom, so that's 1/3. If I put a 0 in for x right here, 3 to the 0 power is 1. And now we can get off to the races. 3 to the first is 3. 3 squared is 9. 3 cubed is 27. Now let's graph these. Again, I'm going to start with the y-intercept. Notice those are the same. Hint, hint. That's very important to understand because whenever x is 0 and you put it in the exponent, you're going to get y is 1. Because anything to the 0 power is 1. So let's go from there. 1, the other one, this one was 1, 2. This one's going to be 1, 3. And then this is 2, 9. About there. And so you can see, and if I keep going this way, -1, 1/3. -2, 1/9. So when I'm trying to say to you guys, that touch the x-axis, it's not supposed to touch it. It's supposed to just above it. You can see that, okay? The point I'm trying to make is there a difference? Yes, but it's so subtle that when you just draw it, you're not really going to see much of a difference as this number changes. Now, they are going to ask you for things like this. What's the domain? What's the range? Is there an asymptote? And they're going to also ask you about end behavior again. So all of these things just never go away. First try they didn't. They're definitely not going away this try. It's a point of emphasis throughout this entire new Algebra 2 concept, okay? So let me check something. Just needed some space. So what I haven't said yet is, you've seen that these two exponential functions are very similar. So if I was to say, hey, what does this look like? I have no problem with you guys. Remember, 0, 1 is like your go-to spot, and then it's just going to go up. So you see these now all of a sudden are added to these. You're just going to see the repetitiveness of it so that you don't have to make these charts all the time. So having said that, what's the domain of this. Now, the red one's going to be the same as the purple one. It's going to be the same as this. They're slightly different, but the domain's the same. So how far left does it go? Forever left. How far right? Forever to the right. Yes, it's screaming up, but we're talking about going to the right. Width. So there's our domain. Range. How low does it go? Well, this is our asymptote. Notice the graph is trying to touch the x-axis, but it doesn't. So my asymptote is the x-axis, or you can call it what it is. It's a horizontal line, y equals 0. Now, let's talk about the range. How low does it go? Well, it tries to get down to 0, but it doesn't touch it because this is an asymptote. How high does it go? It goes up forever. Now, this whole thing called end behavior, you have to get in the habit of just knowing it's wanting you to talk about as the graph goes left. Where does it go vertically? That's what end behavior is asking. Well, as this graph, if I walk along this graph going left, where's it going vertically? Well, y is great. So y is approaching 0. So my end behavior here is 0. Okay? It doesn't touch it, but it's heading towards it. So my end behavior there is 0. How about as x approaches positive infinity? Well, that means we change the guy's direction. He walks to the right. Where does the y value go? Up and up and up. So that would be infinity. And if that confuses you a little bit, we're going to hit that pretty hard. Okay? So don't panic. Hopefully you're paying attention first trimester. A lot of transformation. In my first trimester, I used this a lot. Remember, if a is negative, it's going to go over the x-axis. If b is negative, it's going to go over the y. Plus c means left, minus c means right. This is going to go up if it's positive, down if it's negative. Essentially, there you go. There's your rules for transformations. Now, it says graph this. Well, what you have to think is, notice this has a 3x to the x power. 3 to the x power. So technically, they're saying, let your parent function be this. You're like, well, I don't know what that looks like. Yes, you do. So, remember, 0, 1 is our go-to, and it kind of goes like that. They all do. Okay? So, this is my purple one. I'm going to make this one red based on the change. The only change is there. There's a negative out in the front. Well, that's my A. And if that's negative, it's going to flip it right on over the x-axis. Now, let me pause this a second so I get my words right. Okay. So over the x-axis, take a look. Here's the x-axis. So really, that negative makes any positive y value negative. You see, this is a positive y, positive y, positive y, positive y. That's 0, 1. So think about that. So now that negative is going to make it 0, negative 1. So it's literally going to flip it right over the x-axis. So this would be like this, and this would be like that. I said I was going to do it in red. I blew it. Okay. So that should be red. Make it red. Okay. Now I'm going to try to make this one black based on our rules. Notice it's the parent function, which is right here, which is the purple one, but now we're going -4, which is my D, which means take the purple one and just drop it 4. 1, 2, 3, 4, and then just simply do your best job trying to draw that, okay? Now there's more to it, but I'm running out of time. So I'm going to take care of the easy question before I run out of time, and that's, is there an asymptote for the red one? Yeah, you can see it's coming up and it's trying to touch the x-axis, so it's the x-axis. Now, are there any intercepts? Yeah, it's right there, 0, -1. I got to be done. So there's a part 2. I'm sorry about that, you guys.